It's just a brief slide deck that's going to talk about how we, in physical database design, about data types, right? So I haven't really talked about data types in my other videos, but I wanted to talk about, just all these different data types and kind of give you a brief overview in some of these. And lots of different database engines have different data types you can work with, but I wanted to give you some sense of what these look like. So basically, in every database table, every single column has to have a data type. They're always going to have one data type. The data type determines what kind of values you can store in the column. Sometimes we call this domain integrity, right? It's a domain constraint or a domain integrity. In other words, it defines exactly what type of data can be in that column. So, for example, numeric data types only store numbers. Character data types can be words, numbers, and other characters. There's other ANSI data types, right? So some of these data types are standardized by ANSI, and you'll see some of these as we go through these slides. One thing that's important to note is that in your database designs, you want to not only show your tables and your columns and your relationships, the foreign keys and the primary keys, but you also have to show the data type. And if that data type has a variable length, you have to indicate what length you want to use for that data type. So here's some common numeric data types, right? So big integer is an 8-byte integer. You can see there an example of how big it can be. You've got a standard integer, right? They're pretty big too, right? 2 billion, that's, decent size. Small int, tiny int, a bit, which is 0 or 1, decimal, which can, be have a variable precision and can be up to 10 to the 38th, right? And every database engine has its own rules about, how big these are. These are different in all the database engines. So for example, for MariaDB and MySQL, we can look these up and see what the specifics are. These are all just from ANSI. So they're pretty common across most database engines. But again, these are common numeric data types. Interestingly, when you're designing a database, you have to think about these things because, look at integer, for example. We might be tempted to use int as our data type for, say, the primary key, right? Because it's just the number to identify something. Well, if you look at the maximum value of an int is 2,147,483,647. That means if you're going to have more than 2 billion records for a single table, then an int is not going to be big enough, right? You have to use a big int. And the difference between an int and a big int is either 8 bytes or 4 bytes, right? 8 bytes is not that big. So, maybe it's really not that much more space just to say, let's just use 8 bytes in case we have to go big, right? Or money, which is 8 bytes, right? Which could be a pretty large number. And again, they could be negative or positive. And you could do the same thing with a bit, right? So technically you could have 4 billion records if you had an int, because you could start with negative 2 billion, work your way up to 0, and then go into the positive digits, right? You could theoretically do that. I've seen people do that to fix it, right? They make their primary key an int and then realize, years and years and years later, they're running out of space. They're running out of numbers. Sometimes people don't realize it till it's too late, right? One day somebody goes to insert a new record and the database won't let you do it because it says, the number's going to be too big when I increment to the next value. So then they kind of patch it by um, allowing the sequence to go negative, and then they just start decrementing from 0, and then now you can buy yourself some time until you can update the data type for that column. So again, we have to think about these things when we're designing a database. Think about how big those values need to be. Here's some common date time, right? So date time is a special type of value. Yeah, you could use character data for a date and time in theory, right? But then you couldn't do calculations for date and time. You couldn't have you couldn't add 3 days to a date and expect to get the right value back. But because it treats it as, a date time, you can do those types of operations on a date time value. And also it can automatically validate, right? You can't put February 29th or February 31st, right? That's never a valid date, February 31st. So it won't let you put those types of values if you define the data type as a date. It'll make sure that it's actually a valid date and a valid time. And you can do all the operations again that are supported by date and time. Then you got character data types. So there's char, varchar, nchar, ntext. Different database engines again have different terms for these different character data types. But char is pretty universal. So is varchar. And varchar is one you'll find in something like Microsoft SQL Server, but you're not going to find that in MariaDB as an example. Um, I'm going to talk about the difference between char and varchar. So there's variable length and then there's fixed length, right? So you can see the char is a fixed length, and then variable is a variable length. What both of them you have to define a maximum length, right? So if you make a data type char, you have to indicate in your database design what the largest possible length for that field is, right? It could be 255 if you want to use the max. It could be 12. It could be 16. So, for example, if I'm creating a column for first name, I could arbitrarily say that, my data length is 20, meaning that you can't have a first name in the database that's more than 20 characters. Are there first names that are more than 20 characters? Probably, right? They're not very common. So somebody would have to, at the application level, uh, somebody would have to make sure that any name over 20 characters gets truncated. If they forget to truncate or there's no code that does that in your application, when the insert attempts, it's going to fail. So then you'd have to write some kind of trigger in your database to handle that. And if you take a database development class, you'll learn all about how to write triggers and store procedures and functions and things like that that can handle those types of issues. But again, it's something that we have to think about. And if we make these columns too big, right? So if it's a fixed length and you make it too big, you might have a lot of empty space in your database. And I'll show you what I mean in a couple slides here. So again, for character type data, we have to come up with a specific, we have to think about what's the specific character data type we want to use. There's also character encoding. So Unicode is, there's ASCII, which is just basic encoding, right? I think most people are familiar with ASCII, and you have like a table of all these hexadecimal. They're 8-bit, right? So 1 byte is an ASCII character, which means you only have 255 possible characters with ASCII. Well, the problem is, in all the world's languages, there are more than 255 characters, right? Different languages have different characters. So for example, Japanese has a lot of characters, so you can't just use 8-bit. So Unicode extends ASCII, so you have more characters. So in some databases, you have to also define what the character set is. In this class, I'm not going to ask you to define character sets, right? I'm just going to ask you to come up with some of the basic data types and their lengths. There's other data types beyond numeric. So I talked about the basics, right? So there was character data, numeric data, and then date time type data. And then you have these other ones like image, binary data, variable binary data, XML, for example, and JSON, and dynamic columns in MariaDB and MySQL, which we're going to talk about. So there are certainly other data types. There's also spatial data, like in Oracle, you can have GPS coordinates and spatial data on matrices and for images and things like that. So lots of neat things you can do with these other data types, but they're not universally uh, they're not universally accepted, right? We don't see them in every database. So so when you go to create your tables, we're going to do this in the next unit. So in the unit after this one, I'm going to talk about how to create our database from a database design. We're going to use SQL code to do that. We could use SQL Yolk or Oracle's MySQL Workbench to manage our MariaDB, for example, or MySQL if you're using MySQL. There are tools and things like Microsoft SQL Server and Oracle. Just about every database engine has some graphical tool that you can use to create your tables, but again, you can also code them in SQL, which you can see an example there at the bottom. And we'll do that together in the next unit. We'll try to create some databases, and we'll do an exercise around that. I just want to talk real quickly about variable length versus fixed length, right? So if you were using a fixed length, your records will look something like this, right? So the first, if you think about it, your table is a collection of records, right? And those records have columns. So in my example here, I have a table that has 3 records, right? So you see my 3 rows, and each one of those little boxes that you see represents a single character, right? So the first column is 8 characters, the second column is 8 characters, the third column is 8 characters. But let's look at that middle column, right? Let's say the middle column is first name. And in my second record, I have the first name set to Brian. That's my first name. Well, if, let's say for some reason I have to change that name in that record, right? I have to change that column's value. Because it's a fixed length, I can change it in place where it sits in the physical file system, right? This is a physical file. A physical file is just a bunch of ones and zeros, right? And those ones and zeros are all contiguous in these files. And if I want to change Brian to Brittany, for example, which is my wife's name, it fits, right? I could just replace those characters. I just rewrite, those 8 characters in that particular column, and everything's fine and everyone's happy. That is a fixed length. I set the fixed length to 8 characters. It can't be any less. It can't be any more. If you're not using all the characters in the fixed length, it just leaves them blank, but they're still there, right? The placeholder is there for those additional characters. We're just not using them. Okay. So that is a fixed length. Now, what if we use variable length? The cool thing about variable length is it's going to use less space, right? You can see here that in my first record, my first name only has 4 characters. In the second record, it has 5. In the third record, there's only 3, right? So instead of using all 8 characters for every single record, I'm using only the number of characters that I actually need. And again, all the bits are contiguous, so it just squeezes them all together. This is great because the variable length is great because it saves a lot of space, right? If I had made my first name 20 characters because I'm trying to account for longer first names, but most first names are half that, right? I think, if you think about most of the names that most of them are going to be under 10 characters, right? So it's kind of overkill to have 20, but you got to have, that data length just in case somebody comes along with an 18 character first name. So that's going to be a lot of wasted space in your database. So use variable and it's going to use a lot less space. And you're probably thinking, gee, why don't I always use variable length, right? I'll tell you why. So think about this. What if I want to update my first name? It's Brian right now in that second row. What if I try to change it to Brittany? Well, look what happens. It's not going to fit, right? Because the next column, it's going to overlap into the next column. It's like a buffer overflow, right? The database engine is going to say, well, I can't do that. I have to instead of putting it in the existing column or the column in the existing row, instead it makes a new copy of the entire row, right? And puts it at the bottom. So now we have an entirely new row and we delete the old row and we remove it, right? So the problem here is that every time you update a variable length, if there's not enough space in that for a variable length, if there's not enough space to put the new value that you want to insert or that you want to update, it has to get rid of the old row, create a new row at the bottom, and then it's going to keep creating new rows. And what you're going to end up with over time is that table is going to get very fragmented. It's going to have lots of empty space sitting in it. So now you're using even more space than you had in the first place, right? Because you're tombstoning all of these rows. It doesn't actually remove that other row. It just tombstones it, meaning this row is dead. Nobody can use this because it created a new version of it, but it's still space that's being used. So how do you fix that? You have to get rid of all of that empty space. So periodically, the database engine is going to go through and it's going to remove all of this unused space and it's going to compress everything back up to the top of the file. So now I have a smaller file. I got rid of all that free space. It's now much more efficient. And then over time, I'm going to get back to that scenario where I've got all this empty space. So if you have a column that's going to be updated often, right? If it's a oftenly updated column, variable length is probably not a good idea, right? Again, this is one of those things that as a database designer, as a DBA, as an administrator, you have to kind of make this judgment call of, and when you're looking at performance in your database, you might notice that, you're having a performance problem when people are working with a certain table when they're doing updates, and you might identify, this could be one of the things you're looking at is, okay, well, they're always updating variable length columns, and that's why my table is constantly getting fragmented, and we have to rebuild the table, right? Which takes time and it's effort, and the database is using resources to do that. And when you have a lot of fragmentation, it takes longer to look up records and you have to rebuild indexes and things like that. There's we'll talk about indexes later, but there's this whole cascading list of things that has to happen to support that. Whereas with the fixed length, a lot of those problems go away. We just use more space. Right? So again, you have to kind of consider all this stuff and think about what's important in your in your design. So that's all I wanted to talk about with data types. So when you create a database design diagram, right? So you're done all this stuff. We now know how to convert our ER diagram to a database diagram. We know how to do our normalization. I talked about all the different data types. in your final design diagram, you're not only going to show the tables, you're going to show the attributes, you're going to start the foreign keys, the primary keys, the relationships, just to make sure there's some clarity, even though it's inherent in the design. But also you want to show the data types and the length. If it's the data type that has a variable length or some length that you have to set, you have to show that in that database design, because we're going to take that database design later on and we're going to use that to build our actual database. And the design should answer all of our questions about how to build our database. Um, so that's it. So that's everything you need to know about database design.